Welcome back. Today we're exploring data curation and cleaning at scale, one of the most important but underappreciated aspects of building LLMs.
The phrase garbage in, garbage out has never been more relevant in large language model training.
Let's start with the basics. What does data curation actually involve?
Data curation is the process of collecting, filtering, cleaning, and organizing training data to maximize quality and diversity.
For LLMs, this means processing massive amounts of text from the internet and other sources.
The first step is data collection. Where does all this text come from?
Common sources include web crawls like Common Crawl, which archives billions of web pages,
Books from sources like Books 3 or Project Gutenberg,
academic papers from Arxiv, PubMed, and other repositories.
code from GitHub and other open source platforms,
Wikipedia, and other reference materials.
and sometimes licensed datasets like news articles or specialized corpora.
The raw data from these sources is extremely messy.
Web pages have HTML markup, ads, navigation menus, and boilerplate content.
There are duplicates, near duplicates, and spam,
Low quality content like automatically generated pages or gibberish.
and sensitive content like personal information, copyrighted material, and harmful text.
So, data cleaning is crucial. Let's talk about deduplication first.
Deduplication removes exact and near duplicate documents.
Exact deduplication is straightforward. Hash each document and remove duplicates.
Near deduplication is harder. You want to detect documents that are mostly the same but not identical.
Common approaches use minhash or simhash to create compact signatures of documents.
Documents with similar signatures are likely near duplicates.
You can then cluster documents and keep only one representative from each cluster.
Why is deduplication important?
Duplicates waste compute. The model sees the same content multiple times, learning nothing new.
They can cause memorization. The model might overfit to repeated content.
And they can bias the model toward duplicated topics or perspectives.
Research shows that deduplication significantly improves model quality.
Now let's talk about quality filtering.
Not all text is equally valuable for training.
You want coherent, informative, well written text.
One approach is using heuristic rules, filter out documents that are too short, have too many punctuation errors, or lack proper sentences.
Another is using a classifier trained to distinguish high quality from low quality text.
You might train a classifier on curated high quality sources like Wikipedia versus random web pages.
Then score all documents and keep only those above a threshold.
Some approaches use language models themselves for quality scoring.
Compute perplexity on a reference corpus. Documents with lower perplexity are more similar to the reference and likely higher quality.
Let's discuss content filtering for safety and legality.
You need to remove personally identifiable information or PII names, emails, phone numbers, addresses.
Regular expressions and named entity recognition can detect some PII.
But it's challenging to be both thorough and avoid false positives.
Some PII is context dependent. The name John in a story isn't PII, but John Smith 123 mains might be.
You also need to filter harmful content, extreme violence, hate speech, harassment.
This is done with keyword lists, classifier models, or manual review.
But defining what's harmful is subjective and culturally dependent.
Copyright is another major concern.
You might remove copyrighted books or articles if you don't have rights to use them.
Some organizations honor opt out requests from content creators.
The legal landscape around training data is still evolving.
Now let's talk about topic and domain diversity.
You want balanced representation of different topics, domains, and perspectives.
If 90% of your data is about technology and 1% about arts, the model will be biased.
You can classify documents by topic and ensure minimum representation across categories.
Or use clustering to identify and balance different content types.
Wikipedia categories, website domains, and language model embeddings can help with classification.
Some datasets explicitly mix different sources in controlled ratios.
For example, 60% web, 20% books, 15% code, 5% other.
Let's discuss language identification and filtering.
If you're building a multilingual model, you need to identify the language of each document.
Language detection libraries like Langid or FastText can classify languages.
You can then balance representation across languages or filter to specific languages.
Be aware that some documents are multilingual or contain code switching.
Now, what about document level versus paragraph level filtering?
You might filter at the document level, keep or discard entire web pages.
Or at the paragraph level, extract good paragraphs from mixed quality documents.
Finer grain filtering can retain more high quality content but is more complex.
Some pipelines do multiple stages: document filtering, then paragraph extraction, then sentence level cleaning.
Let's talk about data contamination prevention.
Contamination is when test or benchmark data appears in training data.
This inflates evaluation metrics. The model has memorized answers rather than truly learning.
To prevent this, you need to identify and remove benchmark data.
N-gram overlap detection can find documents that contain substantial overlap with benchmarks.
Some organizations maintain lists of benchmarks and systematically check for contamination.
It's tricky because benchmarks are constantly being created.
Now let's discuss data formatting and normalization.
Text needs to be standardized. Convert to consistent encoding like UTF-8.
Normalize white space, handle special characters, and deal with different line endings.
Some pipelines normalize Unicode, expanding ligatures or combining characters.
For code, you might preserve formatting or normalize indentation and style.
Markdown, LaTeX, and other markup might be kept, removed, or converted.
The choice depends on what you want the model to learn.
What about synthetic data generation?
As high quality human generated data becomes scarce, synthetic data is increasingly important.
You can use existing models to generate training data for new models.
For example, generate diverse question answer pairs or creative writing samples.
The risk is model collapse. If models are trained on each other's outputs over generations, quality might degrade.
But carefully used synthetic data, especially for specific capabilities, can be valuable.
Let's discuss data mixture tuning.
Even after curation, you need to decide how to mix different data sources during training.
Common sources, domains, or languages might need to be upsampled or downsampled.
This is often done through experimentation, try different mixtures, and see what performs best.
Some organizations use smaller models to test mixtures before committing to large scale training.
Now, what about updating datasets over time?
The internet is constantly changing. New content is created, old content is removed.
Regular recrawling and curation keeps training data fresh.
But this raises questions about reproducibility. Training on different data snapshots gives different models.
Let's talk about data provenance and documentation.
It's important to track where data came from, how it was processed, and what filters were applied.
This helps with debugging, legal compliance, and reproducibility.
Data cards or dataset documentation describe the curation process, sources, and known limitations.
Transparency about training data builds trust and helps users understand model behavior.
Finally, what are the human costs of data curation?
Much of the safety filtering relies on human annotators who review harmful content.
This work can be traumatic and is often outsourced to low wage workers.
There are ethical questions about the working conditions in data annotation.
Automation can reduce human exposure, but complete automation isn't yet possible for nuanced decisions.
So, to recap, data curation involves collecting, deduplicating, filtering, and cleaning massive text corpora. Quality filtering improves model performance and efficiency. Safety filtering removes PII and harmful content. Topic diversity and language balance are important. Contamination prevention maintains valid evaluation. And data quality is as important as quantity for model success.
Next episode, we're discussing optimizing for deployment, making models practical for real world applications.
Thanks for listening.
Until next time, keep learning and stay curious about AI.